Lightweight Kubernetes Deployment on AWS with k3s. This podcast is brought to you by Business Compass LLC. We are an Amazon Web Services advanced consulting partner. We build and migrate workloads to Amazon Cloud. Our website is businesscompassllc.com. Our phone number is 973-638-2228. Our email address is contact@businesscompassllc.us. Kubernetes is a powerful container orchestration tool, but running a complete Kubernetes cluster on bare metal can be complex and resource-intensive. k3s, a lightweight Kubernetes distribution by Rancher Labs, simplifies this process while retaining most of Kubernetes' powerful features. In this podcast, we'll walk you through deploying a 4-node k3s cluster on AWS EC2 instances, launching a MySQL RDS instance on a private subnet, installing k3s on the cluster nodes, deploying a NodePort service to make the pods accessible, and configuring Nginx to route traffic to the pod's AWS account with necessary permissions. Basic knowledge of AWS, Kubernetes, and networking concepts. AWS CLI and Kubernetes installed on your local machine. Step 1. Set up AWS EC2 instances. 1.1 Create EC2 instances. Bastion host, a T2.micro instance in the public subnet. Master node, a T2.medium instance in the private subnet. Worker nodes, 3 T2.small instances in the private subnet. Ensure the Bastion host has SSH access to the master and worker nodes. 1.2 Security groups. Bastion host security group, allow SSH, port 22, from your IP. Master and worker node security group, allow SSH, port 22, from the Bastion host and all traffic within the group. Step 2. Launch a MySQL RDS instance. Create a MySQL RDS instance in the same VPC and private subnet as your EC2 instances. Ensure that the necessary security group rules are followed to accept connections from the Bastion host. Step 3. Install k3s on cluster nodes. 3.1 SSH into Bastion host. SHI your key.pem ek2 user at Bastion host public IP. 3.2 SSH into master and worker nodes from Bastion host. SHI your key.pem ek2 user at master. Node private IP SHI your key.pem ek2 user at worker node 1 private IPs. I your key.pem ek2 user at worker node 2 private IPs. SHI your key.pem ek2 user at worker node 3 private IP. 3.3 Install k3s on master node. curl sfl https://get.k3s.io, sheesh. 3.4 Install k3s on worker nodes. First, get the token from the master node. cat/var/lib/rancher/k3s/server/node token. Then, install k3s on each worker node. curl sfl https://get.k3s.io. k3s_URL equals https://master node private IP. 6443 k3s_token equals your node token shesh. Step 4. Deploy a NodePort service. 4.1 Create a deployment. Create a deployment YAML file, for example, deployment.yaml. AP version, apps/v1. Kind, deployment. Metadata. Name, my app. Spec. Replicas, 3. Selector, match. Labels. App, my app. Template. Metadata. Labels. App, my app. Spec, containers. Name, my app. Image, your Docker image. Ports. Container port, 80. Deploy the application. Kubernetes apply fdeployment.yaml. 4.2 Create a NodePort service. Create a service YAML file, for example, service.yaml. AP version, v1. Kind, service. Metadata. Name, my app service. Spec. Type, NodePort. Selector. App, my app. Ports. Port, 80. Target, port, 80. Node, port, 30007. Deploy the service. Kubernetes apply fservice.yaml. Step 5. Configure Nginx to route traffic to pods. 5.1 Install Nginx on Bastion host. Sudo Amazon Linux Extras install Nginx 1. Sudo systemctl start Nginx. Sudo systemctl enable Nginx. 5.2 Configure Nginx. Edit the Nginx configuration file. Sudo v/etc/nginx/nginx.conference. Add the following server block. Server. Listen 80. Location. Proxy_pass http://worker node 1 private IP 30,007. Proxy_set_header host $host. Proxy_set_header x real IP $remote_address. Proxy_set_header x forwarded for $proxy_add_x_forwarded_4. Proxy_set_header x forwarded proto $scheme. Restart Nginx. Sudo systemctl restart Nginx. Conclusion. By following this podcast, you've successfully deployed a 4-node k3s Kubernetes cluster on AWS EC2 instances, launched a MySQL RDS instance, installed k3s on the cluster nodes, deployed a NodePort service to make the pods accessible, and configured Nginx to route traffic to the pods. This setup provides a lightweight yet powerful environment for running Kubernetes workloads on bare metal infrastructure. Thank you for listening to our podcast. Please share this podcast, visit our website, and follow our social media links.